Unit 8, Area and Solids. Preview video 8.1, Part 2, Area of Quads and Triangles. Sit tall, close your eyes. Ready? In through your nose. Inhale. Hold your breath. And birthday candle. Taking a look here, don't forget the date, time, and location. We're continuing to talk about area of triangles and quadrilaterals. The last lesson in class, we talked about triangles and rectangles. So here in a trapezoid, if I go like this, a trapezoid is essentially the area of two triangles. The area of a triangle, any triangle, is going to be base times height. Base times height over 2. Base times height over 2 is the area of a triangle. Now there's two triangles. And we have one triangle there, base times height, but we have basically two different bases. So we're going to call this one base 1. This would be the base of that triangle, base 2. Because that one's obtuse, the height would be out here, technically. But you can see that you have the same height for both these triangles. You have the same height, but you have two different bases. Keep that in mind. You have two different bases, but you have the same height. So for a trapezoid, the area of the trapezoid, if you go like this, I just need you to see where this equation comes from. It's basically one triangle base, first base, times the height, base times height, over 2, plus the second base times the same height, over 2. So if we simplify that, we're going to take, just circle the height here, and it's like backwards distributive. We're going to take the height out. So area of a trapezoid is going to be the height times the average of the bases. Base 1 plus base 2 over 2. It's the height times the average of the bases, or the average of the bases times the height. Same thing. Base plus base over 2 times height, realizing those bases are the two different bases. That's a trapezoid. Area of a rhombus or a kite, and the reason why rhombus and kite have the same equation is they have this in common. They have, if you trace, please, and do this now, trace one diagonal, trace that. What do these diagonals have in common? They are perpendicular, so that's what they have in common. Therefore, the area is the same. You take one diagonal times the other diagonal. It's diagonal 1 times diagonal 2 over 2. Ta-da! That's how you find the area of a rhombus and a kite. Realize a rhombus also qualifies as a parallelogram, so you can use the parallelogram equation as well. So here's your summary for trapezoids. excuse me, not trapezoids, all quadrilaterals, the entire family of quadrilaterals. So we start with area equals. For a parallelogram, it's simply base times height. Remember, height always creates a right angle. In a rectangle, it's also base times height. Also commonly known as length times width. In a square, your base and your height is simply the side length, so it's side squared. Trapezoid, base 1, base 2, height. So it's the average of the bases, base 1 plus base 2 over 2, times the height. That's a trapezoid. And the rhombus in a kite, one diagonal times the other diagonal, diagonal 1 times diagonal 2. Over 2. Diagonal times diagonal over 2. There is all your quadrilaterals. Right there, folks. This needs to be memorized, friends. Do a couple problems here. I suggest you read this out loud. Get in the habit of reading out loud even as I read. So put your finger right there and out loud. A kite has an area 90 centimeters squared. The longer diagonal is 15 centimeters. Find the length of the shorter diagonal. We have a kite, area, longer diagonal 15. We want the shorter diagonal. Now, visualize. We have a kite. Cross it out. Area of the kite. Longer diagonal. Shorter diagonal. That's your unknown. We always start by writing the equation. The equation is one diagonal times the other diagonal over 2. Circle, plug, chug. Cross multiply, that's going to be 180 equals 15 times the other diagonal. So 15, just so you know as I'm doing this, add 15 goes into 18 at least one time with 3 left over, and 3 0 is 30, so the answer is 12. Technically, it's 12 centimeters. Let's try another one. So look at the process. We read out loud, we drew, we labeled, we did an equation, we circle, plug, chugged. Finger right here, read out loud, go. So now we're going to draw a label list, cross out. We have a trapezoid, we have bases, find the height. So we're told the area of a trapezoid is 160 meters squared. It's a trapezoid, so let's go ahead and draw a trapezoid. The bases, plural, so the shorter base is 12 meters, longer base is 20 meters, and we want to find the height, which is your unknown. Come over here, we write the equation. Area equals average of the bases times the height. So we circle, plug, chug. Area, we circle, circle, plug it in. 160. Base, one of our bases is 12. The other base is 20. And then our height is our unknown. Now you solve. We want to get h by itself. That's the ambition. So we just solved. Our height is 10. Check units, meters. So again, read out loud, write the equation, circle, plug, chug, solve. On that note, this page, give yourself about 2 minutes. Really, really, really try to do this completely on your own. Then restart the video, correct your work. If it's wrong, write a note of correction. If it's correct, giant smiley face. Do this on your own. Pause. Welcome back. Let's take a look here. So rhombus has a side length of 5 feet. So side length of 5 feet, which means a side length of 5 feet all around, because a rhombus has all 4 equal sides. The longer diagonal is 8 feet. So the longer diagonal is 8. So I'm going to immediately split it up, 4 and 4. Find the area of the rhombus. Well, the rhombus is going to be 1 diagonal times the other diagonal, diagonal 1 times diagonal over 2. Let's take a look here. This diagonal is right there, and lo and behold, you don't have it. So what you should have noticed is that you needed to solve for that diagonal. Coming over here, that would be x squared plus 4 squared. Have 2 sides, need third side, Pythag equals 5 squared. X is going to equal the square root of 5 squared minus 4 squared, which means x equals 3. Warning, that's not your diagonal, because if this is 3, that is 3. So our diagonal, if you come down here, that's going to be 6 times our other diagonal, which is 8 over 2. I can take the 2 into either. I'm going to take the 2 into the 8. And 6 times 4 is 24. Therefore, the area of the rhombus is 24, check for units, feet squared. Check your work. If you missed any of this, I expect a written note in the margin. What are you going to remember next time?